Hello guys, today we're going to learn on how to solve super logarithmic equations. We're going to take a review of how to, you might learn this, I'm pretty sure you learned this, but you know how to solve logarithmic equations. So first, let's go say we have log base 2 of x equals 2. And first step is to convert to exponential form. 2 squared is x. So 2 squared is x. I know that 2 squared is 4. 4 equals x, or x equals 4. And make sure you plug in the values because you don't want to get incorrect answers. But what if you need to find the base of a logarithm? Like log base x of, hold on. Log base x of, let's go say 4 equals 2. So first I need to still convert it to exponential form. X squared is 4. Okay, I need to take the square root of both sides, but apply the plus or minus root of 4. Plus or minus square root of 4. The 2's cancel, the radicals cancel. X is equal to plus or minus 4. Plus or minus 2. The square root of 4 is 2, but let's confirm. Let's check. Okay? Okay? To this solution. For x equals 2, we know that log base 2 of 4 is 2 because 2 squared is 4. But for x equals negative 2, log base negative 2 of 4 is not equal to 2. So this is not a solution. Instead, only x equals 2 is the correct answer. Make sure you be careful with logarithmic equations. Okay? So let's go say, yeah. So there's a rule that logarithms can't have like a negative base or negative argument. It needs to be like greater than 0. Greater than 0. Okay? It needs to be greater than 0. So that's what we want. Let's go do super logarithmic equations, but finding the argument. So the super logarithm base 2 of x, let's go start with the simpler one, equals 2. So first, instead of converting to exponential form, I need to convert to derivational form. 2 derivated to 2 is x. Now, evaluate. 2 derivated to 2 is 4. 4 is x. That's the answer. Make sure you plug in, but I know that log base 2 of 4 is 2 because 2 derivated to 2 is 4. Let's go do another one. The super logarithm base 4 of x is equal to 2. I need to convert it to derivational form. 4 derivated to 2 is x. Now, I know that 4 derivated to 2 is 256 because 4 raised to the 4th power is 256. Let's go do another one. The super logarithm base 3 of x. I don't know what happened, but it's fine. It's fine. The super logarithm base 3 of x is equal to 2. I need to convert it to derivational form. 3 derivated to 2 is x. Now, I know that 3 derivated to 2 is 27 because 3 cubed is 27. Now, let's go do a harder one, okay? The super logarithm base By the way, we're gonna have like a version 2, so it's gonna be finding the base in that version. Okay, the super algorithm base. I'm gonna choose base 2 of x equals 3. I need to convert to rational form. 2 rated to 3 is x. I know that 2 rated to 3 is x. I mean 16, because 2 squared squared is 2 raised to the 4th, which equals 16. You might know this one, but it's so easy. The super algorithm base 2 of x equals 4. Convert to rational form. 2 rated to 4 is x. Now, I know that 2, if you don't know, I'm just gonna do the steps. So this tells you the left exponent, or whatever you're gonna call it, tells you how many times to exponentiate the base number. So I need to exponentiate 4 times. Now you can just do it up to down if you want to, but there's 2 methods. Okay, I need to evaluate this part first. Up to down, the evaluating process is a little bit different with integration, 2 squared raised to the 4th power. Now I need to evaluate this part. 2 raised to the 4th power is 16. Now I can break that down into 2 raised to the 8 times 2 raised to the 8. But if you want to do it on a calculator or something like that, you can just type in 2 raised to 16 power on my calculator, and it should give you 65,536. Instead of adding 8, I know that 8 plus 8 is 16. And I know that 2 raised to the 8th power is 256. So 256 times 256. We can do standard algorithm, but not for this video because I already know that value. 256 times 256, if you do the standard algorithm correctly, it should give you 65,536. I don't know what happened to my 3 there, but second way to evaluate that is that you can just do the same process as step 1, but if you know, you can just do 2 steps if you want to make it a little faster. So step 1 is to convert this, and then step 2 is to do the up to down process. Evaluate. You can replace 2 squared with 2 raised to 3, but I know that is 16. I'm just gonna replace this with 2 raised to 3. According to PEMDAS, the higher level operations must go first. So 2 raised to 3 is 16. Again, you get the same answer, which is 65,536. Okay? And let's go do the super algorithm. Base 2 of x is equal to 5. I need to convert it to rational form. 2 raised to 5 is x. Now, I can break that down into 2 squared 5 times. And I know this part is 2 raised to 4. Now I can replace that with 2 raised to 4. I know that 2 raised to 4 is 65,536. Now, if I actually type it on a calculator, I'm pretty sure it's going to give you undefined because of how large the value is. So, I'm going to do this as a correct answer. 2 raised to the 65,536 equals x. That's the correct answer. Now let's go do one more. The super algorithm base 2 of x equals 6. I need to convert it to 10 rational form. 2 10 raised to 6 equals x. Now, I can break that down into... I know that it has 1, 2, but 6 minus 1 is 5. So I need to 2 raised to 2. This is actually a faster process. So 6 minus 1 is 5, which equals 2 10 raised to 2 raised to 2 10 raised to 5. I know that 2 10 raised to 5 is 2 raised to 65,536. I know this is actually exponentially to 2 times larger than this. I know. So 2 raised to the 2 raised to the 65,536 is equal to x. That's the answer. Bye guys. I hope I see you next video.